I am your host today, Scott Emley, Chief Technology Officer and Director of Research here at Tecplot. Our expert today is Dave Taflin, Senior Software Development Engineer. Dave wrote the book, or the code at any rate, on TecIO. Welcome, Dave.
Hello.
Here we go. So there's our smiling faces. So why don't we go ahead and get to our first question. So Dave, what is TecIO?
Well, TecIO is a library of functions that you can include with your own applications that allows you to output Tecplot binary file formats. There are two different formats. What I would call the legacy format, .plt, is output by only the serial version of TecIO. The newer .szplt, or subzone format, is output by both the serial and the parallel, or TecIO MPI versions of the library.
There are two versions of the library, right?
Yeah, what I've been calling serial is what we see as TecIO on the screen, and then the parallel one, TecIO MPI, is based on MPI's I/O routines, and that's designed for applications on massively parallel machines using MPI.
Okay. So our second question is, what's new in TecIO 2017? Go ahead.
Yeah, so in addition to some bug fixes and performance improvements, the big change is that we've added reading capability, and this is both in TecIO and TecIO MPI, that allow you or your program to read .scplt files. We have not added this for .plt. The reading is for .scplt files only.
Excellent. So next question is, how do you use TecIO?
Yeah, so I can't summarize that in a single slide, but let's move on to the next slide and we'll get started with that. And this was a question we got from several users, by the way, and we're happy to go into this. So what I've listed here on this slide are the basic TecIO APIs, the ones that you're most likely to use in your code. And in my discussion, by the way, you'll note I'm dropping the numeric suffix. We increment this suffix each time we change the API in some way. We keep the older ones in the file for backward compatibility. So this allows you to continue linking older code against the latest library without changing your code. So let me go through these APIs. TecIO you use to open a new file. And then for each zone that you want to output, you'll call TecZNE once to open a new zone. Then to output the data for that zone, the variables for that zone, you'll call TecDat repeatedly until you've output all of the data. If your grid is unstructured, or what we call finite element, then you'll also call TecNode to output the connectivity. And then finally you'll repeatedly call TecZNE, TecDat, and possibly TecNode for each of your zones. And then when you're done, you call TecEnd to close the file. Now there are a number of APIs with which you can add text or geometries or custom labels. These things are normally stored in layout files, but there are certain cases where it's advantageous to include text or a geometry in the data file, and these other APIs allow you to do that as well. Next slide, please. So here's an example. It's an excerpted example where I've taken out the non-TecIO code. But this is for outputting a two-dimensional structured grid case. So we first call TecIO and pass it simple data set as the data set title, and you'll note that we're appending a char 0 to that. This makes it equivalent to a C string because the library is written in C++, and all character strings in C or C++ have to end with a null character. So this is how we do it in Fortran. So the data set title is simple data set. The next string contains the variable names. You can see we have 3 of them there, x, y, and p. The next parameter is the output file name, t.plt, which may give you a clue that we're outputting the older .plt format this time. The next parameter is the temporary directory where temporary files will be written to. Then we have a few named parameters where you can't see what we've set them equal to, but file format is going to be 0. That directs TecIO to output the .plt format. File type, there are 3 possibilities there. You can output the full data file type, which includes both grid and solution. But you also have the option of outputting grid and solution as separate files, which is useful for grid steady flow unsteady cases. So you would change file type then to indicate whether you're outputting a grid or a solution file. Debug, if you set that to 1, then you get some diagnostic output to your console. And finally, is double, another integer. If that's set equal to 1, then your file will be stored in double precision. If that's 0, then your file will be stored as single precision. The next call, TecIO opens a zone, and the title you can see is simple zone. The zone type is going to be set to 0, which means a structured or ordered zone. Imax and Jmax will be set to something greater than 1 since this is a 2D zone, and Kmax will equal 1. The 3 zeros that follow that are unused parameters. They're an idea we had that didn't pan out. The next parameter, solve time, is a double precision number that gives you the solution time of the zone. And the remaining parameters, the zeros, the 1, the nulls, those are all more advanced features that are not required for this particular example. They relate to variable and connectivity sharing and a few other things. So we'll just set those to default values. Next, we're going to output our X, Y, and P. You can see I left out the code where we actually calculate and fill out those arrays. So down below we assume that we have arrays X, Y, and P that have already been filled with the values you want to output. And in this case we're going to output each of those arrays in its entirety. Each call to TecDat has the first parameter, the number of values, and the second parameter, the array that contains those values. And the third parameter is whether or not they are double precision. So these have all been these are all single precision arrays because that third parameter is 0. Now you don't have to output an array all at once. You can actually output a variable 1 value at a time, in which case that I there would be replaced by just the number 1 followed by the value that you want to output. But you then call TecDat repeatedly for variable X until you've output all the values of X. Then you output all the values of Y, and finally all the values of P. So you have to output your variable data in order like that. And then finally we call TecEnd to close the file. Next slide, please. Now for SZPLT files, we have added support for partition zones, both finite element or unstructured, and IJK ordered or structured grids. This allows, and this is a common scenario in massively parallel computations. You may start with a single zone out of your grid generator, but you then partition that out into different pieces, each of which is calculated on a different MPI rank or process. And it's convenient then for each process to be able to output the portion of the data that it owns. And this is the utility of partition zones. Then each MPI rank can output its own partition, and they all will get reassembled into a single zone in the SZPLT file. Next slide, please. So here are the partition specific APIs. The first 2 are for the TecIO MPI library only. And I should point out that the second 2 then are also part of the TecIO library, the serial output library, and you might wonder why you would want to be outputting partitions when you're using the serial version of TecIO. I put that in for debugging purposes. It's sometimes convenient to run your simulation code in serial for debugging purposes just on a single machine. The first two calls, however, are for TecIO MPI only, and the first one, Tec MPI init, and you'll note I've dropped the 142 suffix, but it's there in the library. This provides some MPI specific information, in particular the communicator and which of your MPI ranks is going to be coordinating all of the output. One of them has to be the drill sergeant and the others follow orders. The second one, TecZNE map, is called right after TecZNE, and it tells the TecIO library for each partition which MPI rank is going to be outputting that partition. The following two are particular to which zone type you have. For FE zones, you'll call TecFE partition, and you'll call this from each rank that owns one of the partitions. And this has the sort of similar effect as calling TecZNE on an unpartitioned zone. It sort of opens the partition, and then you subsequently call TecDat and TecNode to output the data and connectivity just for that partition of the zone. And then for IJK ordered or structured zones, TecIJK PTN performs the same function. I should note that partition zones are only available for the 3D zone types. We cannot output a partitioned IJ ordered or triangular or quadrilateral 2D zones as partitions. Okay, next slide, please. TecIO has to piece together these partitions back into a single zone, and for finite element partitions it does this using ghost nodes and ghost cells that your code provides. Now these aren't required. If you don't mind your zone looking like a bunch of separate partitions sitting next to each other with overlapping nodes, that's okay. But if you want your zone to be seamlessly connected together and have smooth contour lines and some other benefits of just having a single zone, then you'll need to give TecIO the information it needs to connect the partitions back together, and you do this with these ghost nodes and ghost cells. Ghost cells just aren't output. They aren't really used for anything else. The ghost nodes are really the key, and this is where you identify in one partition which nodes overlap nodes in neighboring partitions. This gives TecIO the information that it needs to put your zone back together again. Next slide, please. IJK partitions are a little bit easier. You just have to identify for each partition where the lower left-hand corner resides in the overall zone. And that's all the information TecIO needs for those partitions. Next slide, please. So here's an example using TecIO MPI of outputting a partitioned brick zone. Obviously, I've taken out a lot of the code, but I've kept in the new parts. First off, as before, we call TecINI to open the file, and this is called from every MPI rank. Secondly, we call TecMPI init to pass it what communicator, MPI communicator we're using, and to identify the so-called main rank, this drill sergeant MPI rank that does a bunch of coordination behind the scenes. I normally just set it to 0, but if you have nodes of different sizes on your parallel machine, you'll probably want main rank to be one of the larger nodes because it does require a little more memory and does a little more work than the other nodes in its coordination tasks. Following this, we're going to call TecZNE, which I've not shown here, and then immediately after that we call TecZNE map to pass TecIO the number of partitions for this zone and an array called, in this case, partition owners, where each element in that array identifies the MPI rank that's going to be outputting that particular partition. Then we're going to loop over the partitions, and each MPI rank, if it owns a particular partition, is going to call TecFEPTN to open the partition, and then call TecDat and TecNode to output the data and connectivity for that partition, including ghost nodes and ghost cells. And then finally, we'll call TecEnd to close the file. And this is done from each MPI rank. Next slide, please.
Okay, good. So on to our next question. How do I get up and running quickly with TecIO?
Okay, so each Tecplot installation includes a directory of TecIO examples, and some of those are also TecIO MPI examples. You'll see in those examples, well, first off, they're called partitions, so brick partitioned, IKG partitioned, and tetra partitioned are going to be your TecIO MPI examples, which also run in serial. And these examples cover pretty much every feature of TecIO and TecIO MPI, so they should get you up and running pretty quickly. Just pick whichever example is doing or is closest to doing what it is that you want to do with your code, and start with that and then modify that code as you need to.
Sounds good. Do you have an academic license?
Well, TecIO itself is free, including TecIO MPI. Tecplot 360EX does have academic pricing available, and for that I would request that you visit the website that we've put in the slide here for more information. And if you're interested in pursuing that, our salespeople will be happy to talk with you about that.
Okay. How is TecIO licensed? Is it compatible with the GPL?
Okay, a couple answers here. The shared library, or DLL, which is installed with every copy of Tecplot 360EX, is redistributable. The second answer is you can also get the source code downloadable from MyTecplot. You have to have a MyTecplot login, but those are free. And we'll give you the URL for that later. But you can download and redistribute the source. Now the source does include a TecIO license agreement.txt file that gives you the specific terms, but in a nutshell, what it says is you have to include that license agreement file with the source code when you redistribute it, which you are free to do. If you modify the source, then you also must add a summary of what changes you've made and send us a copy of the modified source. Now, as far as I can tell, this is compatible with GPL, but I'm no lawyer, so I would recommend if you're looking at redistributing source and you're concerned about the GPL aspects of it to consult with your own legal resources.
Wrong kind of doctor, huh?
Yeah, I'm not that kind of doctor, not a JD.
How does TecIO MPI handle multi-block structured meshes? How does it compare with direct MPI output?
Well, there are a couple of scenarios here. If each of your blocks is truly a separate distinct zone, then you'll want to output each of them as a separate zone to the SCPLT file. However, if each of your blocks represents a portion of a single IJK domain, you can output them as partitions, as we covered earlier, and TecIO will piece them back together as a single zone. Now, as to how it compares with direct MPI output, we've designed this to be easy, so it should be easier than writing your own MPIIO code. The execution speed may be slower depending on what you're doing. In particular, and I'm hearkening back to a customer who was helping us test out this library, and he was writing thousands of zones that were about 10 by 10 by 10 nodes in each dimension, so 1,000 nodes total. MPI, or TecIO MPI, is not optimized for writing gazillions of tiny structured zones. That said, it should still be faster than serial output, where you are transmitting each of these zones to a single output node and outputting them in serial fashion. We do get some speed up over that. So
now we have had somebody tell us that they can optimize their Lustre file system, right? Or they can change parameters to improve speed?
That's right. One of our customers achieved roughly an order of magnitude speed improvement by changing from the default striping to 64 stripes, which I think was the maximum for his particular file system. So I definitely recommend you check the documentation or check with the system administrator for if you're using a parallel file system, and increase the striping for your TecIO output.
Great. So for parallel grid steady, flow unsteady solutions, can I write the grid file only once?
Yes. As with TecIO previously, TecIO MPI and the SCPLT format support separate grid and solution files. So you need to write the grid file only once, and you do that first. And subsequently, for each of your time steps, you can just write a solution file that contains the variables that change from one time step to the next. I should say, however, that currently for SCPLT output, whether from TecIO or TecIO MPI, all the data that you feed it are stored in RAM until you call TecEnd. So if you've got many time steps, and you're trying to write them all to a single solution file, you do risk running out of RAM. So in that case, you'll probably want to write one solution file per time step to avoid running out of RAM.
Yes, and we have a story on the backlog for actually creating a flush option so that you could write them all to one file but flush them out one time step at a time. Hopefully that'll be getting in this spring for the spring release. So that would make it so that's less of a problem.
Right.
Does TecIO MPI have any limitations I should know about?
Yes, as I think I've mentioned before, but it's worth repeating, TecIO MPI outputs only .scplt files, not .plt files. And as I just mentioned, when outputting scplt, all of your data are cached until TecEnd is called. Thirdly, parallel efficiency is still a work in progress. We do have one customer who wrote their own parallel output using using MPIIO routines, and now they're not writing .scplt files, but for whatever format they're writing, they found that they got better parallel efficiency than TecIO MPI. We have another story in our backlog to investigate that further and hopefully increase the parallel efficiency. But as I said before, we still do get a significant speed up over serial output.
Okay. What about your new client-server product?
Yeah, well, it's very exciting. We'll probably have to have a separate presentation for that, but here are the basics. It allows Tecplot 360 EX to load .scplt files only, not other file formats, but it can load them from a remote server efficiently. This is beneficial when, as is commonly the case, your massively parallel solution is just too big to transfer via FTP or SSH or whatever. So you want to leave it on or very close to the simulation machine and yet still view it with Tecplot on your local machine. So you can remotely load these files then and view your data without having to transfer all your data around. It includes user authentication and data privacy or encryption using SSH, standard SSH authentication and port forwarding, otherwise called tunneling. So you have state-of-the-art security with this. It's another add-on on the Tecplot side to load remote data, and this is using SSH protocols to ensure authentication and privacy. The server runs on the remote machine and it runs under your own user login, so installing it and executing it requires no admin access, so it should be convenient for customers to use.
Yeah, that's good. So I think we're close to the end of the questions that we've gotten from beforehand, and we have some that have come in. So let's take a look at those. The first question that I see in the pane is, how do you convert SCPLT to PLT? You want to take that, Dave?
Sure. So you'll need a version of Tecplot 360 EX that loads SCPLT files. And Scott, help me out here. Was that 2015 R1 or R2?
That loads SCPLT files. I think it was It first started with 2014 R2, I believe, but you need something, anything that with an EX extension should be able to read an SCPLT file. Although files written with later versions of the file, you know, may not be compatible with earlier versions. So we're backwards compatible. We can always read older files with the newest Tecplot, but not necessarily read the newest files with the oldest Tecplot. So you're probably best off with the later version of Tecplot, a new version of Tecplot.
And from then, of course, you just writing PLT files remains an option with Tecplot. So once you've loaded the SCPLT file, you're free to output it as PLT if you want.
Yeah, and by the way, going the other way from PLT, or for that matter, other formats, pretty much any format that Tecplot supports will, you know, that the Tecplot will read. You can do the same sort of thing where you can read it into Tecplot and write it out as SCPLT files. And you can do it in batch with the -convert flag. And it'll be just like a command line converter, if you do that, it does not check out a license. So you could, for instance, with the server, have a version of Tecplot out on the server end that you could use to convert whatever file format you have to SCPLT for use with the server. And it doesn't have to be, you don't have to have a licensed server. It'll run unlicensed, provided you use the convert flag. Let's see what the next question is. What is the future of the PLT format? Do you plan to continue to support it with MPI write or batch preplot transition from SCPLT?
Yeah, so Scott, I'll probably need your opinion on that. As far as I can tell, we're not developing the PLT format further. We really look at SCPLT as the future of Tecplot. We are, however, continuing and will continue to support it in its current form. So none of the PLT files that you currently have are going to be orphaned at any point.
Yeah, one of the problems with the, you know, if we were to support it with MPI, one of the problems is that it's really not well designed for writing as the partitions to the file from the separate MPI ranks, because it requires all the data to be continuous for a zone. So if you had multiple partitions in a zone and you had to write them in a continuous fashion into the file, that would require, I would think that wouldn't be very efficient. What do you think, Dave?
Yeah, well, for ordered zones, there are some MPIIO features that would help us out with that. For unstructured zones, I don't see any way around that.
Yeah. So I think my feeling is these formats will merge, and so they probably won't. From the point of view of the customer, you probably won't see I mean, much difference between PLT and SCPLT, but for the time being, they're separate formats, and we're focusing on the SCPLT format.
And speaking of time, it looks like we're just about out. I see some more questions online here, so I think we'll probably have to take those offline and
Okay.
finish up to be respectful of our attendees' time.
All right, that sounds good. So let's go ahead and go forward. So I wanted to let everyone know how to download the TecIO format. So Dave?
Yeah, so if you just go to tecplot.com/TecIO, you'll be prompted to log in with your MyTecplot login, which, as I said, you can establish for free, and you'll then be taken to the TecIO download page where you can get the source.
Okay. Well, and thank you for joining us today, everyone. You'll be receiving an email in the coming week with a link to the recordings and also to the remaining questions. We'll have answered them, and you can view the answers there. Again, if you want a TecIO library, you can go to tecplot.com/TecIO, as Dave just mentioned. And if you want to additional help, you can just contact me at scottemlay@tecplot.com. Thank you again. Really appreciate everyone attending, and we'll be having more of these sessions in the future. Dave?
Yep, thank you for joining us, and happy tech plotting.